This is section 2.4, simplifying radicals. The learning goals for today are as follows. We're going to start by adding and subtracting like radicals, simplifying radicals by finding perfect square factors, multiplying a radical with a binomial, and then multiplying binomials with radicals. So we're going to start by adding and subtracting like radicals, and in order to do so we have to define what a like radical is. So like radical is a radical that has the same radicand. So in this case, 3 root 2 and 2 root 2 are like radicals because they have the same radicand. So if we look at this right here, they have the same number underneath the radical symbol, right? And they are also have the same, well, they also have the same index. It's not written in here, but they have an index both of 2. So because they have the same radicand and they have the same index, they are like radicals. And we can add and subtract like radicals much in the same way we would perform algebra. So for example, if we have 3 x's and we added 2 x's, we would have in total 5 x's. I'm going to skip all the way down to the bottom because I think this proves the point. You can think of this right here, 3x's plus 2x's gives you 5x's, okay? 5 root 3's minus 2 root 3's. Well, how many root 3's would we have left? We would have 3 root 3's left. Okay, so if you have 5 root 3's and you take away 2 root 3's, you have 3 root 3's. Okay. You can also simplify radicals by finding perfect square factors. So for example, we can take square root 12 and we can split that up, the 12, into the 4 times 3. Well, which one of these is a perfect square? 4 is a perfect square. So square root of 12 is equal to the square root of 4 times 3. Then we can split that up into the square root of 4 times the square root of 3. And since we know that the square root of 4 is just 2, right? This is just right here. That's just 2, square root of 4. So then 2 times root 3 is 2 root 3. So if you tried that on your calculator, if you tried square root of 12, find the answer. Now also try 2 square root 3 and find the answer. You'd find that they are the exact same thing. Here's another example. Simplify 2 square root 27. So again, what we need to think about is we need to find perfect square factors. And what I mean by that are, okay, let's look at 27. Are there 2 numbers that multiply to 27? One of them is a perfect square. And if you're not sure what I mean by perfect squares are like 1, 4, 9, 16, 25, right? So this is like 1 squared, 2 squared, 3 squared, 4 squared, so on and so forth, okay? So that's what a perfect square is. So let's think about 27. 2 numbers that multiply to give me 27. One of them is a perfect square. Okay, well, what about 9 times 3? 9 is a perfect square. So I can take that now and I can say, well, that's the same thing as saying 2 square root 9 times the square root of 3. I know that the square root of 9 is just 3. And the square root of 3, well, we can't evaluate that. It's an irrational number. It goes on forever. So I keep it as square root 3. So this would be, I can multiply the 2 and the 3 together, and I get 6 root 3. And that's my final answer. So again, if you took your calculator and you multiplied 2 times the square root of 27, that would be the exact same thing as 6 times the square root of 3. Okay, so far we have added and we've subtracted like radicals, and now we've simplified radicals by finding the perfect square factors. Okay, so we simplified, like, say, for example, square root 12 into 2 square root 3. Let's go up here to example 1. Simplify these radicals. Well, the first thing I'm going to do is I'm going to check, are these like radicals? Well, the radicand in each of them is 3. And they all have an index of 2. So they have the same index and the same radicand. These are definitely like radicals. So I just need to think about this, and I can do this in my head. If I have 4 root 3's, and then I take away 5 root 3's, then add 2 root 3's, how many root 3's would I be left with? Well, I can start here. 4 minus 5 root 3's would give me -1 root 3's, and -1 root 3's plus 2 root 3's just gives me 1 root 3, which I can write as just simply root 3. Now, if I was to look at this example right here, example 2, you would see that, okay, this is a bit strange here because I've got 4 root 3, then 3 root 20, minus 12, plus 6 root 45. This does not look like I have any like radicals. However, we can simplify this root 20 and this root 12 and this root 45. And we can simplify those and see if they produce like radicals. So let's start simplifying this. Okay, well 4 root 3 I can't do anything with. So 4 root 3, that stays the same. Plus 3, and then I think about 20. What are 2 numbers that multiply to 20? And one of them has to be like a perfect square here. Well, 4 times 5 gives me root 20. So square root of 4. So square root 4 times 5. Okay, yeah, that's the same thing. 12, okay, I think about 12 again. What are 2 numbers that multiply to 12? And one of them has to be a perfect square. Well, 4 times 3 gives me 12. So I can say, okay, 4 times 3. Plus 6. And then I think 45. 2 numbers that multiply to 45. One of them has to be a perfect square. Well, if I think about the numbers that multiply to 45, I think about 9 and 5, and that works out because 9 happens to be a perfect square. Okay, so what am I doing here? Like, why did I need these to be perfect squares? Well, this is going to be 4 root 3, and then I can split this up right here into 3 square root 4 square root 5 minus square root 4 square root 3 plus 6 square root 9 square root 5. Okay, the first one again doesn't change, but this square root 4 right there, that's just 2. And then I have square root 5. Again, that square root 4 is just 2. And then that square root 9 is just 3. Continue simplifying here. 4 root 3 plus 6 root 5 minus 2 root 3 plus 18 root 5. Okay, now, as you can see, I've gone from this complicated expression where it looked like nothing was a like radical to an expression where we have multiple like radicals. So which ones are my like radicals? Well, 4 root 3 and -2 root 3, those are like radicals. So I can definitely subtract those. And then 6 root 5 and 18 root 5, those are like radicals as well because, again, they have the same radicand and they have the same index. All right, so if I have 4 root 3 and I take away 2 root 3's, I would be left with 2 root 3. If I have 6 root 5 and I add 18 root 5, that would give me 24 root 5. So that's my final answer there. I can't simplify any further because root 3 and root 5 are not like radicals, so this is where I have to stop. So there we go. We have something again. No like radicals initially, and then we simplify, and now we have like radicals. Okay, so here we go. That actually is the first 2 learning goals of today. We're adding and subtracting like radicals, and we simplified radicals, right, by finding perfect square factors. Okay, we simplified radicals by finding perfect square factors. Here we go. Okay. Now what we're going to do is we're going to look at multiplying a radical with a binomial and then multiplying binomial radicals. Okay, so this right here is no different than what you've seen before. When we have a radical on the outside and we have these brackets, we can just apply the radical to the inside. And what I mean by apply, it really is just multiplication. So this right here, root 3 times root 6 is literally root 3 times root 6. And then root 3 times negative 1 is literally negative root 3. Okay. But we can see right here, if we have, like, for example, root 9 times root 3, I can go backwards and say root 9 times 3. So I'm going to do that right here. I'm going to go backwards. Instead of saying, like, root 3 times root 6, I'm going to say all of root 3 times 6 minus root 3. And root 3 times 6 is root 18 minus root 3. And root 18 is the same thing as saying root 9 times root 2 minus root 3, right? And this is good because root 9 right there is a perfect square. So then I have 3 root 2 minus root 3. And that's my final answer right there. So I distributed in the radical. I combined the radicands. I noticed that 18 could be split up into 9 times 2, and 9 is a perfect square. So root 9 simplifies to 3, and I would have 3 root 2 minus root 3. And that's my final answer. Okay, so that is an example of multiplying a radical with a binomial. I got a radical, and I multiplied it with a binomial. Now what we're going to do is we are going to multiply binomials that have radicals. So again, this is no different than what we've seen before. We're going to FOIL. Okay? And again, FOIL is just the distributive property. So I'm going to go ahead and start multiplying these together. Okay, root 3 times 2 root 3 is the same thing as saying 2 root 3 times root 3. Remember, the order of operations, the order of multiplication doesn't matter. Root 3 times 2 root 3 is the same thing as saying 2 root 3 times root 3. And then root 3 times negative 4 root 5 is the same thing as saying negative 4 root 3 root 5. Again, I just changed the order of multiplication because remember, the order of multiplication does not matter. Now, insides, 2 times root 5 root 3 plus 2 root 5 root 3. Okay, so that's multiplying these two terms. And then the outside, minus 4 root 5 times root 5. So again, multiplying the root 5 times the root 5 times the negative 4. Okay, there we go. And now I look over here and I've got root 3 times root 3. Well, root 3 times root 3 is basically like saying root 3 times 3, so root 9. Okay. Minus 4 root 3 times root 5 is the same thing as saying, again, 3 times 5 plus 2, 5 times 3 minus 4, and here 5 times 5 is 25. So you might see initially right there, like 2 root 9 is the same thing as saying 2 times 3, because square root 9 is 3, minus 4 root 15 plus 2 root 15 minus 4 root 25. Well, square root 25 is just 5, so I'm actually going to erase that right there, and I can just actually put in 5. Okay, so this 2 times 3 is 6, and now as you can see, hopefully we've got like radicals right here. So minus 4 root 15s plus 2 root 15s is minus 2 root 15s. and then minus 20. And so now I have negative 14 minus 2 root 15. And I can't simplify this root 15 any further because there are no two numbers that multiply to give me 15, and one of them is a perfect square. So if I think about the factors of 15, 1 and 15, 1 is a perfect square, but that doesn't help us. And then if I think about 3 and 5, well, 3 and 5 multiply to 15, but the square root of 3 is not a whole number, and the square root of 5 is not a whole number. So 3 and 5 are not perfect squares. So there's nothing I can do here. I just write root 15. Okay, so there we go. That is simplifying after we have distributed. And that takes us to the final expectation for today, which is multiplying binomials with radicals. Thanks for watching.